Exciting news from the AMBHER project. A new paper on 3D printed catalyst structures has been published by our colleagues at CNR, Engie and Eindhoven University of Technology. As additive manufacturing of periodic open cellular structures is gaining interest in structured catalytic reactor research, this work seeks to thermo-hydraulically compare the well-known Kelvin lattice structure with the lesser-researched BCC and gyroid lattice structures. Open cellular structure samples were produced using the LPBF, laser powder bed fusion technique, based on CAD designs, resulting in cylindrical models of 10 mm diameter and 15 mm height. The following feedstock materials were used for the printing: aluminum silicon magnesium alloy, Inconel 625, and copper chromium nickel silicon alloy. Using a combined CFD and experimental approach, the selected open cellular structures are characterized and subsequently subjected to numerical analysis. To discern the influence of the cell type on pressure drop, distinct structures were tested, all maintaining a similar porosity and specific surface area. The Kelvin structure consistently registered the most pronounced pressure drop, followed closely by the gyroid. Conversely, BCC showcased the least pressure drop, behind the Kelvin under similar porosity. Such distinctions can be attributed to the unique designs of the cells. This design induces a more energy-intensive flow pattern within the matrix, amplifying energy dissipation. Conversely, the gyroid lattice's streamlines depict a highly tortuous path, also leading to increased friction and, thus, a higher pressure drop. Meanwhile, the BCC structure provides a relatively unimpeded flow. When evaluating solely on the basis of pressure drop, the BCC design is notably superior. While pressure drop is an important metric, it's just one piece of the puzzle. As many industrial applications involve significant heat transfer, it is essential to consider both pressure drop and heat transfer characteristics for a more holistic evaluation of the open cellular structures. The volumetric heat transfer coefficient is the metric used to rank the structures. The Kelvin cell consistently presents the highest values. In evaluating optimal structural design, a balance between pressure drop and heat transfer is essential. Although the performance between structures is fairly similar, a ranking can still be determined. When maintaining constant porosity, the gyroid curve remains dominant until reaching a specific velocity, at which point the BCC becomes preferable. Thus, gyroid configurations seem to offer superior momentum and heat transfer characteristics at lower velocities, whereas the BCC structure demonstrates superiority in the high-velocity range. The paper has been published open access in the Chemical Engineering Journal. Follow us for more results on the AMBHER project.